Good morning, folks. Well, I guess good whenever you're watching this. So today we're going to be talking about the chain rule. It's one of the last kind of derivative rules that we need to know moving forward, and it's also one of the most important. So the chain rule essentially says that if I have a composition of functions, I take the derivative of the outermost and work my way to the innermost, multiplying all the while. So notice here, right, I have f is my outermost. I do that derivative first, and I leave everything else on the inside of my function the same. Then I go to g of x, I do that derivative, and leave everything on the inside the same. Then I do the derivative of the inside part, and whatever that comes out to be. And it doesn't have to be only three parts, right? If we have multiple things, then I'm just going to keep multiplying the derivative from the outside to the inside. A lot of teachers teach this as like a M&M type deal, like you're breaking the candy shell or something. I don't know. I haven't looked into the activity to understand why they're doing that. So I'm just going to get into it. Really, that's the best way that you're going to start making the connections. And here we're just going to find the derivative. So before, you would have to break this up with the power rule and actually distribute 3x plus 1 times 3x plus 1, then use your power rule, then come up with the derivative. This case, with the chain rule, what I'm going to do is the outermost thing that I see, right, is that 3x plus 1 squared, which I can use the power rule with and say that this is 2 times 3x plus 1 to the first. Right, so I'm taking away one of that exponents. Then I look inside a little bit more, and I see 3x plus 1. Well, the derivative of 3x plus 1 is just 3, so there would be my derivative. So this would come out to be, what, 6 times 3 would be 18x plus 6. So let's see if we get the same thing. 3x plus 1 times 3x plus 1. So 9x squared plus 6x plus 1. So if I do the derivative of that, right, this is y prime is 18x plus 6. So same thing, but it's going to be a little bit less work, especially as you get going through it, because this step will be unnecessary. So is this one, and then really so is this one, unless you're talking about a multiple choice part. Because you can leave your answer like this and move on with life. Remember, you don't have to distribute these things, and we don't want you to. We don't want you to lose silly points because you are distributing something and you multiply something wrong. So anytime on a free response, leave it unsimplified. Okay, doing the next one, e to the x, right? But it's e to the 3x. So the biggest thing I see is e to the x. So I will do y prime is e to the x, but 3x. And then I see the next innermost part is my exponent, and the derivative of 3x is 3. So there would be my derivative. Alrighty. Oh no. We were on C. Okay, so the biggest thing that I see is this 5 times 2 minus x cubed to the fourth, but really it's that 5 times something to the fourth. So I'm going to use my power property with it. So y prime is 20 times 2 minus x cubed to the third. Then I look inside a little bit more, and if I look inside, I see 2 minus x cubed, so times the derivative of that, which would be negative 3x squared, and there would be my derivative. Okay. Next one. Biggest thing that I see is the square root, so that is that thing to the 1/2, so I could say that g prime is 1/2 4 minus 3x squared to the negative 1/2. And then I look inside a little bit more, and I have 4 minus, that's not what I wanted. I have 4 minus 3x squared on the inside a little bit more, and that is going to come out, when I do the derivative of that, as negative 6x, and there's no other functions inside. So again, you're going to have multiple ones where there's like a lot more steps to this. They can get pretty brutal. But we're starting out pretty simple. All right, then this next one. All right, so the big thing that I see is this is a quotient, but what I can do with this is I can rewrite this as negative 3 a minus 2 to the negative 4. And then it becomes a much simpler chain rule problem, because m prime of a would be 12 times a minus 2 to the negative fifth, right? And that was that whole part using the power property. And then I have the derivative of the inside, which would just be 1. So if you want to do times 1, you can, kind of as a placeholder to remind yourself that you did the chain rule. But other than that, you can just leave it like that. Or you don't have to put the times 1 either. That's fine. All right, so this one. This is where we're starting to get a little bit more interesting, right? So the first thing that I see is what I have is a product property, right? I have this thing times this thing. And when I do the second derivative, or the second part here, right, I'm talking about all of this. When I do this part, I'm going to have to use the chain rule with that part. So first, really, the biggest is I see that I need to use the product property. So I will do 1/2 x squared, and then I'm going to do the times the derivative of my second part, which, if you think about this, is 16 minus x cubed to the 1/2. So this would be 1/2, 16 minus x cubed to the negative 1/2. And then times your inner part there, which would be negative 3x squared. All right, so that was going outside to inside. Well, that's bad to highlight pink and pink. That doesn't make any sense. All right, and then plus the derivative of the first. So 1/2 times 2. So this would come out just as x times the second. All right, so that one was kind of an ugly one. But again, we don't have to simplify this thing. So I'm going to leave my derivative looking just like that. He's so pretty. All right, part G here. I have a quotient, but on the outside I have that x cubed. So the biggest thing that I see is that, oh, this is a bad problem because I wrote it in terms of x and t. Boo. Okay, I'm sorry. I need to fix this real quick. Let me fix the problem. Okay, that makes me much happier. So again, what I see, the biggest function is I have a, interesting, right, I have that cubic on the outside. So I need to do the chain rule first with this one. So the s prime of t is 3 times 3t squared minus 2 all over 2t plus 3 to the second, using the power property with that big thing. Then as I look inward, then I have my quotient property. So my quotient property, I'm going to have to do low d high minus high d low all over low squared. And then I will be done. So low d high, so low d high would be 6t minus high d low all over low squared. And that would be it. You can leave your derivative just like that. No need to simplify, try to do any of that stuff. It is really not worth it. Okay. All right. This one seems to give us some issues sometimes. But really, again, you got to remember, you're looking outside to inside. So the biggest thing that I see is that giant parentheses with the squared on the outside of it. So h prime of x would need to be, sorry, my hand keeps hitting something and it keeps flying away from me. So 2 plus x squared plus 1 to the fourth to the first power, essentially. Then as I look inward, I need to do the derivative of all of the inside part. And the derivative of this 2 here is going to be 0, so I kind of just lose that. And really looking at this part, this is another chain rule in itself. I keep going inward. All right, so I have that 4 exponent up there. So I'm going to pull that 4 exponent in front, take one away, and multiply it. So this will be 4 times x squared plus 1 to the third. And then if I look inward again, then I just have x squared plus 1 on the inside of that parentheses as well. So I would need to make that times 2x. and there would be my derivative. Again, you just keep working your way inward and inward and inward. That's the whole deal about the chain rule. Okay, I think we only have 2 more, at least for day 1. I made a bad problem again. Okay, we have a better problem. So this one, I like to rewrite it. Maybe because I'm just not as confident about these exponent properties. All right, so that is the cube root of all that junk. So if I look outside to inside, I need that 1/3 exponent first. So I'm doing my derivative. I have a prime of b equals 1/3 2b cosine x plus e to the 3b to the negative 2/3. Then times, I need to look inward. So now I'm looking at the derivative of my inside part. And this first one, I didn't change that x. I'm so sorry. B, You will not get a problem like this where you have multiple variables, at least not in calculus yet. There's a whole course devoted to that, which is called Cal 3. Okay, we have all b's, we have all b's. All right, so this first one, right, when I do the derivative of the inside here, that's my whole inside part. And with this first one, I need to recognize this as a product rule. So there's going to be a bunch of stuff to that where I need to do 2b times negative sine of b plus 2 times cosine of b. Then I have the derivative of this next part, which is my e to the 3b. That is still using the chain rule, and I would have e to the 3b times 3. All right, similar to that one that we looked at before. Super ugly problem, right? But just take it slow, move little bit by bit, go outside to inside as you go, still using all of your rules of differentiation. Yeah, and again, I would not try to even simplify this at all. Literally, this problem exists to see if you guys can understand the chain rule. All right, so here, again, still using the chain rule, my outsidemost function is just secant. So I'll do y prime is secant, and keep your inside the same. Even though it's secant tangent, you need to make it x squared in both instances. Then you have the derivative of x squared, which is 2x, and that would be it. That would be your derivative. Okay, I think that's the end of day 1. So day 2's homework, and really I think this is day 3's for your homework that you have listed, because we just split it up to 4 days. So chain rule is really, really important moving forward. But this is a new derivative that you guys will know. The derivative of natural log, which is the same thing as derivative of absolute value of natural log, is 1 over x. That can be proven by saying y equals ln of x. And if I rewrite this as e to the y equals x, and I take the derivative of both sides, this is going to use something called implicit differentiation, which you haven't learned yet, but you are about to. But this becomes dy dx times e to the y equals 1. So dy dx equals 1 over e to the y, and e to the y we defined already as x, so dy dx is 1 over x. Implicit differentiation is not too horrible. You're taking the derivative of both sides. So what you do is you say that you are going to take the derivative of this thing as is, which is e to the y, and then using our chain rule, I need to take the derivative of the exponent and the derivative of y, just like we were doing before when we had like y equals x. You didn't realize it, so we didn't talk about it too much. But when you do the derivative of y, right, we're doing the derivative of both sides, the whole thing. So then dy dx would equal 1 is what we would write, because we're taking the derivative of y. So the derivative of y, that's why these things go together, in terms of x. So the derivative of x in terms of x, right, dx that divides and it makes 1. We haven't really talked about it too much yet, but that's really what's going on with implicit differentiation. When you take the derivative of y, you need to say you are taking the derivative of y. Okay, but that's your proof. So let's use it. So differentiate the following. E cubed ln of x. So this is just a straight up product rule. So f prime, and I'm lying, it's not a product rule because e is not a function, e is a value. E is approximately 2.718, I don't remember. I could be getting that wrong. I'm sorry if I am. But it's a value, is all I'm trying to get at. So if that is some value, then this is just a number. So really I'm just taking the derivative of ln of x and multiplying it by e cubed. So e cubed times 1 over x. So this would be e cubed over x. All right. Part B here is a chain rule, but it's really not, because remember your base is e, so really this is x. So it looks complicated, but using your properties, this derivative is just 1. If you want to prove it with the chain rule, then we would have f prime, so I'd have 1 over the thing inside times the derivative of the thing inside times the derivative of the exponent. So then these e to the x's will divide out and get me to the derivative of 1 as well. All right. So again, here I definitely need to use the chain rule. So h prime of x is 1 over the thing inside, which will be 2x over x plus 3, times the derivative of the thing inside, which is a quotient rule, so I need to do low d high minus high d low. So low d high minus high d low all over low squared. And there's no further inward to look, so that would be it. Yes, you could rewrite that if you wanted to, right? You could flip that first fraction, you could divide out some of the x plus 3's, you could divide out other things, you could divide out a 2, but I'm not going to worry about that right now. Okay, ln of cosecant. Right, again, still using the chain rule. Gots to, because I have a function within a function. So f prime of t would be 1 over cosecant of t times the derivative of cosecant, which is negative cosecant cotangent. Again, you could simplify that to negative cotangent, whatever. Okay. Still using the chain rule, and I like to write this sine squared, because this sine squared, we could treat it as sine times sine and use the product rule, and that would get you a correct answer. But I prefer to rewrite it, or at least think about it, as sine of x squared, because that's what it is. It's just saying it's sine times sine. So if I think about it like this, it's easier for me to see that I'm using the chain rule here. So then I have y prime equals 1 over 1 plus sine squared times 1 plus 2 sine. Right, that's using the chain rule times cosine. Right, so as I'm looking here, when I had the derivative of this part, I had to pull down the 2. So I had 2 times sine of x to the first, and then when I did the derivative of the inside, that's where I'm coming up with this cosine right there. Again, you can simplify if you want to, but not necessary, so why do it? Okay, determine the tangent and normal lines to this function at x equals pi over 4. So if I want the normal and the tangent lines, I need to have a slope, and I need to have a point. So to find the point, f of pi over 4 would be cosine of 3 pi over 4, which is negative root 2 over 2. And that's unit circle stuff. You guys need to brush up on it a little bit if you're still having some trouble with that. If you need some guidance as to where to look with unit circle stuff, it's going to start coming up a lot more. Let me know and we can talk. Okay, so there's my point. Now I need to find the slope. So f prime would be negative sine of 3x times 3. All right, so I'm looking outside to inside. The big thing is just cosine. and then the inside is 3, so I need to multiply by the derivative of that. Now I can find the slope, so f prime of pi over 4 would be negative sine of 3 pi over 4 times 3. Sine of 3 pi over 4 is positive root 2 over 2, so times the negative is negative root 2 over 2 times 3 is negative 3 root 2 over 2. There is my slope. So that is of the tangent line. So for the tangent, right, I would have y minus, well, really plus root 2 over 2 equals negative 3 root 2 over 2 times x minus pi over 4. There's my tangent. And for my normal, it's the same thing essentially, but I need to take the negative reciprocal of the slope, so it would be 2 over 3 root 2. Right, just remember normal is perpendicular. Okay, day 3. So day 3 introduces the exponential stuff. So I'm doing the derivative of a to the u, so this is any number, right? So this would be like 2 to the x, like we're going to look at in this first part down there. So a is a number, u is a function. So instead of writing x, I just kind of help you guys with the chain rule. The outermost, well, this is going to be a constant, but let me show you why it is what it is. So if I take a to the u equals y, right? So we would want to take the derivative of both sides in this because I'm trying to find dy dx of a to the u. Well, I don't really know how to do it yet, but I can use my log properties to rewrite this as log base a of y equals u. And I don't know how to do that left side either, but I can use my change of base property to make this ln y over ln of a equals u. And again, it's important to remember that ln of a is just a constant. And I'm going to multiply that over. So this would give me ln y equals ln of a times u. Now I can differentiate, and again, this is going to imply a little bit of implicit differentiation. So this will turn into 1 over y, because I'm taking the derivative of natural log, so it is 1 over the thing inside, and then times the derivative of the thing inside, which is my dy dx, equals ln of a, because that is just a constant, and then whatever the derivative of u is. So that's how I'm getting to that u prime. Then if I multiply the y over, then dy dx equals ln of a u prime times y, and y, as we stated, is a to the u. So I'm going to take that and I'm going to make that substitution, and that time getting ln of a times y, or a to the u, times u prime. That is how that one comes about. The next one can be worked out similarly as well, right? It's very, very close. So if you forget these rules, you can always come up with them. So let's see. Get out of here, you. Nobody wants you. No. It was funny in my head. So y equals log base a of u. So again, I'm going to want to rewrite this. So this is ln of u over ln of a. So if I do dy dx, 1 over ln of a, because that's just a constant. Now I have times the derivative of ln of u, which would be times 1 over u times whatever the derivative of the thing inside is. And that's how that one comes about. A little bit simpler than a to the u. Okay, here we go. Let's do a few example problems, and then we will be done. And then you will have lots of time to work on your homework because the chain rule is so, so important. We give you guys 4 days to do this stuff. All right, differentiate. So I have y prime is, what we said, log of a, right? Or ln. ln, I'm sorry. My b. These ones are not used as much. ln of a times 2 to the x times the derivative of the exponent, which would be 1. So ln of, I wrote a, I'm sorry. It is ln of 2, it is your base. ln of 2 times 2 to the x. Right, your base is a, so ln of the base times the thing itself times the derivative of the exponent. Okay, so this one is y prime, 1 over ln of the base, which is 3, times 1 over x, and then times 1 over 1, or just 1, right? Because the derivative of x is 1. So f prime of t, so I have ln of 3 times, let me put it like that, times 3 to the 4t plus 7. And then I have an exponent that has more stuff in it, so I need to take the derivative of the exponent and multiply it as well. Do not get caught. These things do not multiply together, so please do not multiply them together. They do not have the same exponent, so I cannot combine them in any way. Really, there's no way to combine any of this stuff here. That would be the most simplest that you could make this problem. Okay, the next one, I made a bad problem. I'm telling you guys, it is so hard to do online for me. I would much rather have you guys in class and think about these things rather than trying to make notes at 11 o'clock at night and keep up. Okay, golly, and then technology. Natish, make fun of me. Okay, so again, chain rule. So f prime of a is 1 over ln of 4, because I have the log as the whole big picture, divided by, or times, 1 over the thing inside, so 5a squared minus 3a, times the derivative of the thing inside, which would be 10a minus 3. And that would be our derivative. Again, you can combine these things, rewrite them if you want to, but you do not have to. Okay, party. We are so close. I think E and F are our last two. So y prime is 1 over ln of 5 times 1 over the thing inside times the derivative of the thing inside, which is a low d high minus high d low over low squared. You can do it that way. You could also think of this, which is probably what I would do, as x squared over x minus 1 over x. So really this is x minus x to the negative 1. So my derivative here would be 1 plus x to the negative 2. It's most likely what I am going to do. Again, be careful with your scratch work. They do not want to see that on AP test. If you do it far off to the side, and do not put any of your other, don't mix scratch work with answers, because it gets really confusing to read. Okay, so y prime equals, this is going to be a product rule first and foremost, because I have this times this, and then I will have to do the chain rule within those product rules. So I'm going to do the derivative of the first. So ln of 5 times 5 to the negative x over 2 times the derivative of negative x over 2, which would be negative 1 over 2, times the second, so sine of 2x, plus the first, times the derivative of the second, which would be cosine of 2x, times the derivative on the inside, which would be 2.